The home computer era started in 1977 with the three most popular computers, so Apple II, Commodore PET, as well as the TRS-80. But there is always a lifespan, and in 1985 the 16-bit computers started to take over their roles. Welcome everybody on my channel. This is my next video where I'm talking about computer architectures, how they were built, CPUs, some kind of history, and my aim in this video is to cover the period from the beginning, so somewhere around 1981 till 1985 of the 16-bit computers. What is defining a 16-bit computer is the CPU. So let's start with the CPUs enabling those computers. There was no revolution, just evolution. So there is always some kind of forerunning solution. In this case, it was the Texas Instruments CPU, but it was not a good CPU. It was used by TI. They built the TI-99 series on that, but it was much closer to the 8-bit computers than the real 16-bit computers. So the two really definitive CPUs were the Motorola and the Intel series. They both arrived in 1979, but they were totally different. Let me start with the Intel CPU because it has more connection to my previous videos. The Intel already had the 1880, then the 1885, it was a response to the Z80, and 1886, as its numbering shows, it was planned to be a temporary solution, not a permanent one, but finally it is still with us. The Intel developed a much more advanced CPU, and it was the first time when they started to use microcode. It's a good question. It is somewhat similar to a kind of firmware. It is splitting a difficult instruction like dividing two numbers to smaller steps. It is taking more clock cycles, and at the end it has a result. It makes the CPU simpler. That way the designers were able to implement more instructions but still keep the CPU somewhat simple. The 1886 had a small brother. It was called 1888, which was still a 16-bit CPU, so internally it was 16-bit, but it had just an 8-bit data bus. The Intel engineers, to avoid having too many pins on the CPU, implemented a multiplexed CPU bus. This new CPU bus was much more complex because of the multiplexed data and address bits, and as well as it was able to handle multiple CPUs or other coprocessors. The most famous one is, of course, the FPU, so the 1887, but in fact it was not important for the personal computer, so the IBM Personal Computer, because most of the programs were not programmed in a way to utilize it. The 1886 had 20-bit address bus, and they used segmentation. Segmentation means the 20-bit address was calculated based on two 16-bit wide registers. One register is shifted by 4 bits, and then the internal logic just added those two registers, and that way it calculated the final address. So it was much more complicated to use, because if we just use one register, in this case we were able to address only 64 kilobytes of memory at once. Intel introduced 80-188 and 80-286. From now I will just drop this 80 from the beginning, so the 186 and 88, when they were introduced, they were not compatible with the PC, since the DMA and other port assignment were not compatible with IBM PC addressing. This is the reason why you cannot find frequently those in any kind of IBM PC or PC compatible. But the 286 found its way to IBM PC, so the IBM PC/80, but I will talk about it later. The 286 had two important features. The first one was on the hardware side, so it dropped the multiplexed bus. It was easier to use in circuits because there were no need to use additional buffer ICs. The other feature was on the addressing. It was able to use 24-bit address bus if it was switched to the protected mode. The protected mode was introduced to make easier the life of the developers when they are developing something like a Unix operating system, but the protected mode was not really compatible with the original PC. The next Intel CPU, the 386, corrected these problems, but we will get there later on. The Motorola 16800 series was a predecessor of 68000 series, but in this case it looks much more future-proof because it is using already 32-bit instructions. It was easier to use its instruction set, and also the addressing model was much better. But it shouldn't mislead us, because the 16800 was originally really just a 16-bit CPU. If you compare the Intel CPU to the Motorola one, then you can see the Intel CPU can address 1 megabyte, while the Motorola one can address 16 megabytes. To be honest, that was not a big problem at the beginning, simply because that amount of memory was enormous. It really costed a hell of a money, so to be honest, I don't consider it as a big difference, at least at the beginning. In the next video you will see how it became a limitation, but up to 85 it was not a big difference. The Motorola also developed further the CPU, so introduced 68010, which was pin compatible with the 16800, and it was a little bit faster, something like 10%, 15% faster. But the next one, the 68020, was really a big jump forward. It was a real 32-bit CPU. It was introduced in 1984, but in this video I won't talk about it, similar to the 386. Let's leave it for the next one. After the CPUs, let me talk about the machines, and I try to do it based on the introduction. So the first one was the IBM Personal Computer. Some of the naming is a bit odd. At this time, when somebody said personal computer or PC, included all the 8-bit computers or other computers as well. But as IBM started to call their own computer as PC Personal Computer, they've stolen this name. It was an out-of-box at IBM. They could see that the small computers, they are eating up their territory step by step from the bottom. They also tried to develop something like that. For example, there was the IBM Data Master, so they were aware of this problem. In 1980, John Opel, who was president at IBM, assigned a task to William Loeb and William Don Estridge to develop a new computer. What was strange in this assignment is that they developed something out of the box. It was not developed internally, slow processes whatsoever, but they collected everything from the market. What do I mean? They selected CPU from one vendor, they used TTL circuits or special circuits if they were available from multiple vendors, as well as they bought the operating system from an external company. It is really interesting how they selected those components, because they were still influenced by the IBM way. What do I mean IBM way? For example, when they went for the CPU, the Motorola one was better. It was easier to write the code for the CPU, but they were not able to ship in volume, as well as there was no second source at the time when they started the evaluation. They required all those because they had this process where they examined around 1000 of the CPUs and the consistency of the quality. Intel was able to deliver that amount, as well as they had already a contract with AMD for 1885 at that time, so it was very easy to extend it for the 8086, 8088 series. And this is the way how AMD became the second biggest manufacturer for 86 compatible CPUs. But it is a different story. Let's continue with the IBM PC. So they had the CPU family, but they went after the 8088. The reason behind was very simple. The 8088 had just an 8-bit bus, and they were able to use well-known circuits. Simply they used them in previous projects for the Intel 8085 based machines. So this is the reason why I can say that they really used 8-bit machine components in the IBM PC. At the beginning it was not a problem. As an example, let me bring up the DMA controller. It was able to handle only 64 kilobytes of memory. But it was not a problem because the motherboard of the first revision was able to host only 64 kilobytes of memory. If we take a look at the motherboard, we can say it is very similar to the first generation of 8-bit computers. It is using a bunch of TTL ICs, standard production circuits from different manufacturers, so you cannot find any kind of special circuits on board. I heard from many sources that the IBM PC was great because it had slots, it was easy to expand or replace the card. But in fact, it was copied over from other machines. I have two examples. What do I mean? There was the Apple II. It also had its own slots. And it was possible to install, for example, an 80-character card or CP/RAM extension card into those slots. Or there was the S100 bus on the CP/RAM machines, and I tend to say the second one influenced the IBM development team. The other components were also influenced by the existing 8-bit machines, so if we take a look at the graphics, there were two cards at the beginning. There was the CGA and the MDA. The CGA was able to produce 16 colors, but in higher resolution, it was able to use 4 colors at once. My problem here is those 4 colors were predefined, and they were ugly. It was possible to select from 2 palettes. The first one had this blue-pink, so it was ugly. The other one with this brownish, well, it was just simply disgusting. I don't know who decided to use those colors. The positive side of this card was that it was possible to connect it to a television and use a television as a monitor. The MDA, as its name states, monochrome display adapter, traditionally it was black and white or black and green. No matter what, it was not a graphical adapter. But it was really good for office applications because it had a sharp character-based screen. They also bundled a good quality keyboard, which was really important for longer-term use. So an MDA combined with a good keyboard really shows that the IBM aimed the business users. There I see only one drawback, because they forgot to implement the hard drive capability. I don't know how could they miss it, but of course later on other manufacturers and as well as IBM with the IBM XT corrected this problem. The IBM XT has been introduced in 1983, around 1.5 years after the original IBM PC. Hardware-wise, the development was not so big. They haven't increased the speed of the CPU. There was no change on the CGA, neither the MDA. It's worth to mention that there was already Hercules. The small company introduced an MDA-compatible card, which was able to produce the sharp and clean monochrome character-based screen, as well as bitmap graphics. What is really disappointing is the CGA, because if they just add a latch, so it is a simple circuit, then it could make possible to select the 4 colors from the 16. So I do not see why it was not tasked to 1 or 2 engineers to develop a better CGA graphic card. Really, I do not see how they missed this point. What they really introduced is to prepare the XT to handle a hard drive, 1 more slot, stronger power supply, and the hard disk card. But to be honest, there were already companies. Those companies developed cards with their own ROMs to extend the IBM PC. I also have an IBM PC, and with such a third-party card and a Seagate MFM hard drive, it is performing quite well. IBM introduced the IBM AT as the next family member in August of 1984. It was really a step forward because they replaced the CPU, so this is where the 286 was introduced, and speed-wise it was 2 or even 3 times faster than the IBM PC or XT. The 286 meant also more memory, and this is where the original limitations became visible. Because of compatibility reasons, they kept the original memory map from the IBM PC. It had 640 kilobytes of base memory, and there was the upper memory for the expansion cards. I already mentioned 2 of those. So first of all, there was always a monitor card, so let's say a CGA, and next to this one there could be a hard drive as well. The AT had another achievement as well. This is where the enhanced graphics was introduced. It was really a big step forward because it united the best of the CGA and the MDA, and on top of that they even stepped forward. The maximum resolution was increased to 600 by 350, the color palette was increased to 64 colors, and finally the IBM engineers made it possible to select the displayed colors from the palette. The increased resolution and palette made it possible to have a high resolution graphical and character-based display at the same time. There was only one drawback. It required a multi-sync monitor, Because of that, it was really pricey. I've talked about the hardware, but what about the software side? IBM followed the same rule, so they selected something from the market. Almost every 8-bit computer had BASIC, so they approached the company with the best BASIC on market. So this is the point where Bill Gates and Microsoft came into the picture. Bill Gates' mother had a good relationship inside IBM, so this also helped them. Microsoft BASIC was really good at that time, and IBM aimed them just for the BASIC. When they had a discussion with Bill Gates about the operating system, then he recommended digital research and CP/M. But somehow Kildall and his wife missed the opportunity. Kildall hadn't attended on the meeting with the IBM guys, and they were reluctant to sign an NDA, so the IBM guys went back to Microsoft, and this is where Bill Gates said, okay, we can provide you an operating system. They licensed a CP/M clone, later on they completely bought this system, and with some development, this became the first DOS. Bill Gates learned from the mistake what he made when he dealt with Trammell, because when Commodore approached them for a BASIC, they sold for $10,000 or so, instead of asking for a royalty per machine. IBM agreed to permit Microsoft to sell the DOS to any other company. The development of MS-DOS followed the track of the hardware developments. They introduced DOS 2.0. It was in pair of IBM XT. It was really a step forward because DOS 1.0 was not able to handle directories. And then they introduced the DOS 3.0, which arrived in 85 April, so after the IBM 80. And it was really able to handle all the hard drives up to 32 megabytes. If you had a bigger hard drive, you had to partition it. But I can say that MS-DOS 3.0 or 3.3 is the point where we can say it was a stable and solid operating system. But don't forget, it had its roots in CP/M. As I'm reaching 85, I would like to talk about one more thing, which is the clone topic. The first clone was introduced in June 1892. It was just 10 months after the introduction of IBM PC. If you think about that, it was really quick. What made it possible? There are two things. First of all, I already mentioned that Microsoft could sell its DOS to any of the companies. So the operating system was not a problem. But what about the hardware side? At that time, it was not possible to patent the hardware. Additionally, IBM made a perfect documentation. So they documented every bits and bolts, even the schematics was part of the documentation. It made possible to any manufacturer to make a clone. There was only one blocking factor, which was the BIOS. Since the BIOS is a software, there was copyright protection. But IBM documented it as good as the hardware side. It helped the clone maker a lot to write their own BIOS. Since after that nothing blocked these clone makers, they started to flood the market. At the same time, the software library also started to boom. What made it possible? First of all, it was easy to port from the CP/M to DOS, and Big Blue also supported those developers to have a software portfolio. So to summarize the IBM PC, it was not better than the 8-bit machines on the market at the beginning. The IBM 80 really stepped forward. At that time there were a lot of IBM compatible machines. Software-wise, they started with a CP/M clone. Even at Microsoft, there was an aim to switch to a Unix solution, but MS-DOS spread, and there were hundreds of different companies and developers, and they wrote an enormous software library. After IBM Personal Computers, let's talk about the next competitor, Apple. The story of Macintosh reflects how I see the history of computers. I do not believe in revolution, but evolution. It is very rare to see a revolutionary idea to become a successful product. This story starts at Xerox in the early 70s. They released the Xerox Alto. It was the first machine with a graphical user interface and mouse. Since the cost of this machine was around $10,000, only around 1,000 units were produced. At Xerox, they haven't realized that what they developed, but they let the idea to spread. Their laboratories were visited by Bill Gates as well as by Steve Jobs. After this visit, Steve Jobs realized the opportunity and started to work with his team on a machine using graphical interface. This machine was the Apple Lisa. The Lisa was not a successful machine. How could it happen? There are multiple reasons. The first one is the software behind. The developers tried to put everything into the operating system. It had a graphical interface, it was multitask, they developed several softwares, but the hardware was not fast enough for that. Later on, Steve Jobs was expelled from this project. It is already enough to fail, but additionally, the price was too high. It is easy to say it was a pricey failure for Apple, but at the same time, it was the base for the development of Macintosh. Originally, Jeff Ruskin started the Macintosh project, and the aim was to produce a low-cost, easy-to-use machine. However, after Jobs were expelled from the Lisa project, he took over the development of Macintosh. Hardware-wise, the released Macintosh is similar to the original Lisa. It is using the same CPU, so it is based on the Motorola 68000. The memory size is reduced to 128 kilobytes, and it has 64 kilobytes of ROM. The operating system is also a kind of cheap Lisa, so they've dropped a lot of functionality. It is a single-user, single-task operating system, but they kept the graphical interface. After such optimizations, they were able to sell the Macintosh under $2,000. Steve Jobs also realized the importance of the look and feel, so they designed a very stylish all-in-one case for the machine. It was good because it was very easy to set up the machine, but it was bad because it was not easy to expand the machine. During the cost optimization, the developers also dropped the hard drive. All in all, the machine became cheap, but it had limited memory and storage capabilities. The first Macintosh was introduced in January of 1984. Apple started a heavy ad campaign. At the beginning, the sales were really good, but after several months, they had to realize that the Macintosh is not really moving forward. The first revision of the Macintosh was released in September of 1985. It was called Macintosh 512. Its name shows what the developers did. Simply, they just increased the memory size to half megabytes, so 512 kilobytes, which made possible to load bigger programs into the memory. It was necessary because the original 128 was barely enough to run the operating system and a simple program. Apple pushed to the market more and more hardware for the Macintosh, but still the Macintosh missed something. To boost the sales of Macintosh, they required an application which was similar to VisiCalc. Apple II sales started to boost when VisiCalc was released to the machine, so they required something like that. Apple Laser Writer was released for the Macintosh in March 1985. How is it related to the application? It is quite simple. The laser printer, together with the nice graphical interface, was able to produce a nice sharp picture and print it on paper. That time, to make a flyer or a small newspaper or advertisement, they used scissors. So they had the pictures, they had the small printed text, and they just cut, glue it together, and make a copy. There was a company called Aldus. They created a program which made possible to release everything in a digital way, to create the whole layout on the screen and then print it out. This process was renamed to desktop publishing, and it boosted the sales of the Macintosh. Since it happened in 1985, I'm switching over to other computers. It is very hard to decide between Amiga and Atari. Instead of that, I'm going over the two models, so the Amiga 1000 and Atari ST at the same time. The idea behind Amiga belongs to Atari. It sounds a little bit strange. To explain that, I need to jump back to the 70s. Jay Miner worked for Atari in the 70s, and he was responsible for the Atari video computer systems, so the Atari VCS development. To be exact, he was the leader of the integrated circuits development. Later on, he was also responsible for the Atari 400 and 800 development. After the 8-bit machines, he had an idea to develop something based on the Motorola CPUs. Unfortunately, Atari management didn't support that idea. In 1982, he accepted Larry Kapman's invitation and joined Hi-Toro. He got the role to develop a new computer, which was his dream. Later on, because of legal issues, Hi-Toro was renamed to Amiga. So Jay Miner led the development of the Amiga, but there were others as well in the team. So for example, R.J. Mika and Dale Luck. We can say those three guys were the fathers of Amiga, if you can say something like that, but the team was much bigger. Luckily, they molded the signature of the whole team into the case of the first Amiga, so this is what you can see now. But the story is much more complicated, how they reached from the design to a released computer. The story continues with Commodore at January of 1984. That time, Commodore was the biggest computer company. In the previous year, there was a price war between Commodore and Texas Instruments, which affected heavily other computer makers, for example, Atari. But something strange happened in Las Vegas in January. Jack Tramiel, who was the founder of Commodore, and he was the CEO for several years, left the company. There are rumors what happened between Irving Gaud and him, but there are no facts. What we know, he just left CES and the company as well. Amiga guys also participated in the show, and they introduced the first prototype of their new machine. It was just based on breadboard, but they could demo the advanced features of Amiga. They had high hopes to find new investors, but they failed. It happened because of the market crash in 1983. Other companies also suffered. I already mentioned Atari. They lost $1 million per week. So the situation was not so good for Atari, Amiga, as well as for Tramiel. But Tramiel was a tough guy, and he started to prepare his return. He founded his new company called Tramiel Technology. In June, almost at the same time, two things happened. Amiga was at the edge at the time. The leaders put mortgages on their own houses to pay the bills and wages, but finally they got some loan from Atari. Almost at the same time, Tramiel agreed with the owner of Atari and he started a takeover. So he fired everybody and then he rehired one by one the key employees. To keep the company afloat, he sold out the 8-bit machines on stock. There was a need for a 16-bit machine to succeed. This is the point where I should say that Amiga returned to Atari, but we know that it's not true. So what happened? Tramiel started a dirty game, so he tried to push down the price of Amiga. But this trick failed when Jay Miner's team made an agreement with Commodore. Commodore transferred some money to them, and they were able to pay back the loan to Atari at the last moment. Since Tramiel and Atari missed the Amiga opportunity, they had to go for something else. At that point, Tramiel had a group of ex-Commodore engineers. Those engineers followed Tramiel to the new company, and they started a quick development. Somewhat it was similar to IBM PC development. They selected almost everything from the market, but for them, it took just 5 months to develop the new computer and at the same time the new operating system. The Atari ST is based on a Motorola 68000 CPU. There was an idea to develop their own sound chip. Instead of that, they selected a programmable sound generator from Yamaha. They developed a few custom chips, but to be honest, they are not as sophisticated as the Amiga ones, so it was very easy to develop them. But still, I do say that the Atari ST is a better machine than the original IBM PC. I can present based on the display modes how the Atari ST is better than the original PC. It is using the same resolution, so for example 320 by 200. It is able to display 16 colors instead of 4 colors of the CGA, but it is possible to select of these 16 from a palette of 512 colors. If I need to criticize Atari ST, there is one thing: it is really hard to expand. This is because the whole machine was jammed under a keyboard. So in one hand it is a small slick machine, it really looks nice, but in the other hand it is harder to expand than an IBM PC. But what about the software side? The operating system was not an in-house development. They developed it together with Digital Research. Under the hood there is CP/RAM, but it has a graphical interface called GEM. I think they made a smart decision. It is a single-user, single-task OS, so in this sense, it is much closer to the Macintosh. This is why it earned the Jackintosh nickname. Finally, it was released in June 1985, just 1 month before Amiga. With different words, Amiga was released in the same year, but in July. Amiga was the last of the 4, but it was the most advanced. The development took several years, but when it was released, it was ahead of the competitors by several years. It was based on the same Motorola CPU as the Atari or the Macintosh, but the chipset design was very smart. It was able to offload a lot of tasks from the CPU. For example, it was possible to issue just a few commands and scroll the screen. This video is already very long, so I don't wanna invest a lot of time to explain how Paula, Dennis and Agus help the CPU. Maybe if you are interested, I will work on it in a different video. Just let me talk about 2 features. The first one is the screen and its resolution. Not the resolution itself, but the color palette. It was possible to use at the same time 4096 colors in the hold and modify mode. Do you remember the EGA which was able to display 16 colors from a palette of 64 colors? Or the Atari which was able to use 16 colors from 512? Or the Macintosh which was monochrome? I think I do not need to explain that further. The other feature is the sound. The Amiga had stereo 4-channel sound, so 2 channel on the left and 2 channel on the right. It was able to produce sound output based on samples, which was unheard before. You may ask, what about the operating system? I can say that the operating system was also very advanced, but it caused few issues. It was a single user, but multitask operating system. Multitask means, like today, it was possible to start multiple programs and they were able to run at the same time. It had a graphical user interface called Workbench. The original plan was to split the operating system to 2 halves, one half in EPROM and the other half could be booted from a flop disk. But because of the complexity of the operating system, it was not really ready when they launched the Amiga. They overcome this problem in a smart way, so the first half, which should be in ROM, is loaded into the writable control store. It is a kind of write-once memory at the boot, and then it is starting the first half of the operating system from there, and then we can load the Workbench from another floppy disk. It was not good because it really increased the price of the Amiga 1000, but that way somehow they solved this issue. The base memory for Amiga was 256 kilobytes, but it was very common to expand it to half megabyte. Since we have all the 4 competitors, I'm getting to the end of this video, so let me summarize it. The first one on the market was the IBM PC. Its architecture was very close to the machines on the market, so the 8-bit machines. Operating system-wise, it also copied those machines, so it started to use a CP/RAM clone, which became to the MS-DOS. The second one was the Apple Macintosh. It was a cheaper, simplified version of Apple Lisa. It had a very nice all-in-one design, but because of that it was hard to expand the original model. Its biggest advantage was its graphical user interface. Together with the laser writer, it found itself in a niche market called desktop publishing. The third machine was a result of a rushed development. It took 5 months to develop the Atari ST. It combined the previous competitors, so it was based on CP/RAM, but it had a graphical interface similar to the Macintosh. In many aspects, it was a little bit better than the other 2, but it was not revolutionary. It's better to say it was a good but not an excellent product. The Amiga was the last of the 4, and it had the best features. If you compare the graphical or the sound capabilities, it is obvious. The operating system was also ahead of the other 3. But technical features are one thing, market success is another. If you are interested how they evolved and performed on the market, join me for my next video. I hope you enjoyed this one. Wish you a nice day. Goodbye.